So, hello everyone. We're gonna learn. We're gonna try to learn differential equations together. So, I've set up a page here. For basically Laplace transforms. So, I guess let's start there. So, let's think about, like, for example, like what even is a Laplace transform? Like, I'm honestly like not even quite sure. So, I guess it's good to always good to start with. So, let's just get rid of this. So we'll, I guess, talk about like ransom. Let me just get rid of some extra boilerplate. Okay. So what is a Laplace transform? I guess we'll start with a question mark to make it look better. But yeah, what is a Laplace transform? That's pretty. It's obviously very important for thing. And let me just change the title to uh, and then I'll change it to just say like self-guided notes or something. Okay. So uh okay. Yes. So obviously a Laplace transform is basically, well, let's read the book. So it develops this problem, and it just sort of just explains, just plugs in Laplace transform. But so it gives you this problem where there's a salt mixing salt problem. So you figure out the rate where x changes, and then GT changes. So I guess we can introduce Laplace transform somewhat similarly, but I also want to do a little bit of a different approach. So let's start. So I'm like looking up, trying to figure out where exactly this Laplace transform function even comes from. It's obvious that it's somewhat applicable, but so I guess let's start with just talking about what it is formulaically. So I guess I'll add a small little paragraph. describing like given in the equation book following, and I'll add a quick span, then we'll set the HTML properly. And obviously it's given as, in any equation book, it's given as basically f of s is equal to the int e to the negative st f of t, and then obviously dt. I don't think I formatted this right, so let me just check if that's right. Yeah, that's how you do int in LaTeX. And especially if you're doing something in JavaScript, I think this one of the most useful things to do with JavaScript, and especially relating to this type of LaTeX thing, is string.raw. I've talked about before. It helps you like fix a lot of JavaScript formatting problems, like such as this one. So obviously it's equal to this, um, as the following. But what does this mean, and where does it come from? I mean, that's obviously the first question. Like, where do we? What is it like? What's a physical example of this that we can see and understand? So I guess let's start with so I myself don't really understand this. So it's obvious that it's really useful for problems, but so okay, so here's that is a still pond. You disturb it at one point and watch the height of the water there. Yeah, I can imagine that. Instead of a random splash, you So starting with a simple problem, like we can start with a mixing problem, and then we can explain why you need class transforms. So if you have a linear system, if you have a linear system, now which needs a little bit of the good stuff, I guess. The linear system that we're talking about is L of y. I believe it looks like, I don't know, it seems like L of y equals g of t, where g of t uh, g of t is a piecewise. We would normally so we normally have to do two different things separately. So I guess let's just start with a simple problem. Uh, so let's just start with a simple problem. So let's start with like problem statement like uh, so we need to put g of t as a piecewise function, and then let's just establish some initial conditions that can compute g of t. G of t can be something like from the textbook. The textbook samples of g of t is basically in specific conditions. So I just want to see how this looks in lunch. So obviously, it's going to be equal to 2.4, let's say, and then if condition and And then change this to 1.2. So this is assuming so this is obviously assuming that this is basically the salt input concentration, and then so and logically it leads to a situation where f prime of t is going to equal plus 3 over 500 x 3x over 500 is going to equal g of t. We just fix the spacing on this real quick. Okay, cool. Then logically, f prime of t equals 3x over 500 equals g of t. So let's assume that x0 equals 30. So let's just do this problem real quick. So if we're doing this problem, we would have to break up the time interval into two subintervals, and it's constant, and then use muck, determine the general solution for each subinterval, each containing the the commutative solutions. Then you need to evaluate x of 10. I think we should just solve this problem the other way, just to make sure that we know how to do it. So let's do that first, and then we'll sort of expand on this last method, and we'll explain how it works. So also, I made a mistake. This shouldn't be x. It should be x prime of t. Dx by dt. Yeah, I guess let's just do this problem. So all this, we must observe, first of all, that this is basically like we can come up with an integrating factor, that an integrating factor of the form and let's so so instead of obviously this, we can do slash mu, and this string dot raw thing really does help here. So let's e to the power of, I believe an integrating factor should be e to the power of just negative mu x. Sorry, negative px. Sorry. Let me just check. No, it's just p over x. So obviously it's 3 over 500 and t times t. So then multiplying this to both sides, it becomes the following equation, where since it just becomes x mu, derivative of x mu on the left side, so it's derivative of x mu, so it just becomes so we can just, to represent this, the best way I think to do this is just to do a frac. So I'm not too familiar with law text myself, but I believe this might be the best way to represent it. So on the top, it's going to be d dt, yeah, d dt, and then, sorry, d, and then the bottom will be dt. Just make sure that renders properly. I'm not exactly sure. Cool. And then we can put some parentheses, and then obviously it's going to be mu, so it's going to be e to the 3 over 500t times t multiplied by, sorry, you don't even need to multiply by, multiplied by x of t. And then if you multiply this out, it's obviously just x of t mu, x of t, bro, I cannot speak today. So if you look at this equation right here, obviously, if you do product rule here, it's going to be x prime of t mu t, just correct there, and then mu prime of t x of t. So obviously you take this x out, and then there's this 3 over 500 multiplied by e to the 3 over 500 t times 3 over 500, so that's also correct. And then it's going to equal mu gt. It's going to equal, full expression is going to be equal to e to the 3 over 500 times t, and then obviously g of t. So once we've gone here, it's actually not the most beautiful rendering, but obviously we take into both sides, then we integrate to get basically, okay, so it's obviously going to be equal to x of t is going to equal see if this remembered properly. I forgot about dt. Sorry. So this again makes some logical sense, I believe. Then now we just plug in g of t's and solve. Q g of t solve. And the piece lines result x result for x. So yeah, you would get a completely piecewise result of x. Interesting, I guess, but Laplace is just so much more efficient for doing this. Just let's save some update. Let us re-render. Um, okay, so we would get a piecewise result for x. Cool. Instead, there's this other method, which is a Laplace transform. X of s is the Laplace transform, and x prime of t is an algebra. Where g of s is the Laplace transform. So it just sort of goes over the Laplace transform, which is basically just take a differential equation in the t domain. Instead of breaking it in subintervals, doing solutions and fitting constants to get a solution, you Laplace transform and inverse transform. Chapter 7.2 is all just about doing Laplace transforms for simple functions. That's not too hard once you just know the formula. I mean, once you just do this, it's not too hard. Just plug and chug. But yeah, this question really is bugging me. Like, where does it come from? What's a simplified? Okay, so 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 something I found online is like okay, so I guess I have an idea. So for what values of x is negative ln of x imaginary? I'm just like reading and I didn't kind of understand. So T A of T, sorry, A of M, and you're summing up a power series. And you're summing up a power series. You can kind of represent it like Laplace transform. But where, why is this useful for solving differential equations? Okay, I have some idea. So I guess we'll start going for it. I know this is kind of really long. So let's have a function f of t. Let's look at a simple function f of t. T. And let's call it f of t. So obviously f of t um, t where t is f of t. What does it mean for a function to be analytic? So we'll just say it's analytic. Basic. Maybe instead of FT, I could write FT again like this. Where FFT is analytic. So analytic. So it's analytic, and then let's just say, so then the Taylor series can be represented by, so obviously the Taylor series is going to be f prime of t over n prime of n factorial multiplied by x of n. So okay, that didn't work. Why didn't this work? Okay, so obviously then we can let so obviously then we can let this sort of f of n ds equal to some a of n. I think so obviously so that now um that now just becomes a of n. So that now Let me get rid of that n factorial. Ooh, okay, cool. See you then. Okay, so now we have basically the sort of representation for a of n. Now we need to move from this to the form that we have in Laplace transform. So a convenient way to do this would be let s equal negative ln of t. Wait, no, sorry. That's not right. So we need to go from whatever this is, we need to go to an expression where it's now if we approximate n with a continuous and a discrete variable with a continuous variable s. So you can do some approximation and you can get a pretty wait, actually it shouldn't be s. From here I think we should take a moment to just think through exactly like what we're trying to convey here. So how can a of n my point where I'm confused is how can a of n become f of t? Because don't we already have like something else that represents it? So where we have that every n we have a coefficient in a power series and it sums up to be f of t. So we're representing f of t based on this basis function of t of n. Now this makes a lot of sense. Okay, so n is t is the variable, and n is the discrete index. When the plus form, s becomes the variable, and t becomes the index. Power series basically means that you're taking basis functions t of n and you're building f of t by using coefficients and discrete expansion. So now we're using e to the negative st. There's now an integral so now you're taking Laplace transform basically says now what we're looking at is that we are going to look at f of s wait. Yeah, I'm gonna be honest, bro. I don't quite understand exactly where this even comes from. It was like black matter, to be honest. But yeah, we'll end it here, I guess. I guess we've at least sort of understood it. The problems shouldn't be too hard to do. 7.1 doesn't have any problems. 7.2 probably does have some problems, but it's just equal class strengths there. This. We'll see, I guess.